Section 517.13b of the National Electrical Code, or NEC, specifically addresses equipment grounding requirements within healthcare facilities. This section mandates a redundant grounding approach to enhance patient safety and minimize the risk of electrical shock. A core requirement of 517.13b states that an insulated, copper equipment grounding conductor must be installed alongside the branch circuit conductors and all wiring methods used within patient care areas of healthcare facilities. This insulated equipment grounding conductor must be sized according to Section 250.122 of the NEC, which dictates the appropriate size of equipment grounding conductors based on the overcurrent protective device rating for the circuit. The primary function of this insulated equipment grounding conductor is to provide a low impedance path for fault current to return to the source, thereby facilitating the rapid operation of overcurrent protective devices such as circuit breakers or fuses in the event of a ground fault. This rapid clearing of the fault minimizes the duration of any potential shock hazard. It's crucial to understand that the requirement for an insulated equipment grounding conductor in 517.13b applies universally to all wiring methods used for branch circuits in patient care areas. This means that even if the feeder supplying the branch circuit panel board already incorporates an equipment grounding conductor, as permitted by Section 250.118 of the NEC, the insulated equipment grounding conductor is still required within the branch circuit itself. The intent behind this redundancy is to provide an additional layer of protection in the event that the feeder equipment grounding conductor becomes compromised or ineffective. The equipment grounding conductor within the branch circuit acts as a backup, ensuring that a reliable ground fault path remains available even if the primary path is disrupted. Section 250.118 outlines the acceptable methods for providing equipment grounding for feeders. These methods include the use of metal raceways, such as rigid metal conduit, intermediate metal conduit, and electrical metallic tubing, as well as the use of a separate equipment grounding conductor installed within the raceway or cable assembly. However, regardless of the feeder grounding method employed, the requirement for an insulated equipment grounding conductor in the branch circuit, as specified in 517.13b, remains in effect. Now let's delve into the sizing requirements for the equipment grounding conductor as outlined in Section 250.122. This section provides a table that correlates the size of the equipment grounding conductor to the rating of the overcurrent protective device protecting the circuit. For example, if a branch circuit is protected by a 20-amp circuit breaker, the equipment grounding conductor must be at least a 12 American wire gauge copper conductor. Similarly, if the circuit is protected by a 30-amp circuit breaker, the equipment grounding conductor must be at least a 10 American wire gauge copper conductor. It's essential to consult Section 250.122 to determine the appropriate size of the equipment grounding conductor for each branch circuit based on its overcurrent protection rating. There is an exception to the requirement for an insulated equipment grounding conductor in 517.13b. This exception applies when the branch circuit conductors are installed in non-metallic conduit or other non-metallic raceways that are not grounded. In such cases, an equipment grounding conductor is not required. The rationale behind this exception is the non-metallic conduit does not provide a reliable path for fault current. Therefore, the presence of an equipment grounding conductor within the non-metallic raceway would not significantly enhance the safety of the installation. However, it's important to note that this exception only applies when the entire branch circuit wiring method is non-metallic and ungrounded. If any portion of the branch circuit wiring method is metallic or grounded, the insulated equipment grounding conductor is still required. To further clarify the application of 517.13b, let's consider a few practical examples. Firstly, imagine a patient care area in a hospital where branch circuits are wired using electrical metallic tubing. In this scenario, 517.13b mandates the installation of an insulated, copper equipment grounding conductor within the electrical metallic tubing alongside the branch circuit conductors. This insulated equipment grounding conductor must be sized according to section 250.122 based on the overcurrent protection rating of the circuit. Secondly, consider a dental office where branch circuits are wired using non-metallic conduit. If the non-metallic conduit is the sole wiring method for the branch circuit and is not grounded, the exception to 517.13b applies, and an equipment grounding conductor is not required. However, if any portion of the branch circuit wiring method is metallic or grounded, the insulated equipment grounding conductor would be required. Thirdly, let's examine a scenario where a feeder supplies a branch circuit panel board in a patient care area. The feeder is wired using rigid metal conduit, which serves as the equipment grounding conductor for the feeder, as permitted by section 250.118. Despite the presence of the equipment grounding conductor in the feeder, 517.13b still requires the installation of an insulated copper equipment grounding conductor within each branch circuit originating from the panel board. This redundancy ensures a reliable ground fault path even if the rigid metal conduit feeder grounding path were to be compromised. The interpretation and application of 517.13b often generate questions and require careful consideration of the specific details of each installation. To ensure compliance and patient safety, it's always advisable to consult with a qualified electrical inspector or engineer when designing and installing electrical systems in healthcare facilities. In addition to the core requirements of 517.13b, it's also important to be aware of other related sections of the NEC that address grounding and bonding in healthcare facilities. These sections include 517.13a, which specifies the general grounding requirements for healthcare facilities, and 517.19, which addresses the grounding of receptacles and fixed electrical equipment in patient care areas. A comprehensive understanding of these related sections is essential for ensuring a safe and code-compliant electrical system in healthcare settings. Section 517.13 establishes the fundamental grounding requirements for electrical systems in healthcare facilities. It mandates that all exposed conductive surfaces of electrical equipment and the building structure be bonded together to form a low-impedance ground fault path. This bonding is typically achieved through the use of copper bonding jumpers and connectors, which effectively tie together metal raceways, equipment enclosures, and structural steel component. The purpose of this bonding is to minimize voltage differences between conductive surfaces, thereby reducing the risk of electric shock to patients and staff. Section 517.19 focuses specifically on the grounding of receptacles and fixed electrical equipment in patient care areas. It requires that all receptacles and fixed equipment be grounded to the building grounding system through an equipment grounding conductor. This equipment grounding conductor must be sized in accordance with section 250.122 and must be connected to the grounding terminal of the receptacle or equipment. The proper grounding of receptacles and fixed equipment is critical for preventing electric shock hazards in patient care areas, where patients may be particularly vulnerable due to their medical condition. Furthermore, it's important to consider the impact of 517.13b on the design and installation of isolated power systems in operating rooms and other critical care areas. Isolated power systems are often used in these areas to provide an additional layer of protection against electric shock hazards. These systems utilize an isolation transformer to isolate the electrical supply from ground, thereby preventing a single fault from creating a direct path to ground. However, even in isolated power systems, the equipment grounding requirements of 517.13b still apply. The insulated equipment grounding conductor must still be installed in branch circuits within the isolated power system to provide a low impedance path for fault current in the event of a second fault. Now, let's discuss some of the common misconceptions and challenges associated with the application of 517.13b. One common misconception is that the requirement for an insulated equipment grounding conductor only applies to essential electrical systems in healthcare facilities. Essential electrical systems are those that are required to maintain critical functions during a power outage, such as life support equipment and emergency lighting. While it's true that essential electrical systems are subject to more stringent requirements than normal electrical systems, the equipment grounding requirements of 517.13b apply to all branch circuits in patient care areas, regardless of whether they are part of the essential electrical system or not. Another challenge is the proper sizing and installation of the equipment grounding conductor. As mentioned earlier, the equipment grounding conductor must be sized in accordance with section 250.122 based on the overcurrent protection rating of the circuit. It's crucial to consult this section carefully to ensure that the equipment grounding conductor is adequately sized to handle the potential fault current. Additionally, the equipment grounding conductor must be properly installed and terminated to ensure a reliable connection to the grounding system. This includes making sure that all connections are clean, tight, and corrosion resistant. In summary, Section 517.13b of the National Electrical Code mandates the installation of an insulated copper equipment grounding conductor in all branch circuits within patient care areas of healthcare facilities. This requirement applies even if the feeder supplying the branch circuit panel board already incorporates an equipment grounding conductor. The purpose of this requirement is to provide a redundant path for fault current and enhance patient safety. There is an exception to this requirement for branch circuits wired entirely in non-metallic conduit that is not grounded. The equipment grounding conductor must be sized in accordance with section 250.122 based on the overcurrent protection rating of the circuit. A thorough understanding of 517.13b and related sections of the NEC is essential for ensuring a safe and code-compliant electrical system in healthcare settings. By adhering to these requirements, electrical professionals can help to minimize the risk of electric shock hazards and protect the well-being of patients and staff. To reiterate, the key takeaways from this discussion are: firstly, Section 517.13b requires an insulated copper equipment grounding conductor in branch circuits within patient care areas. Secondly, this requirement applies even if the feeder has an equipment grounding conductor. Thirdly, the equipment grounding conductor must be sized according to 250.122. Fourthly, there is an exception for non-metallic conduit systems. Fifthly, proper grounding is critical for patient safety in healthcare facilities. Remembering these points will help in navigating the complexities of electrical installations in healthcare settings and ensure compliance with the National Electrical Code. It's important to remember that electrical codes and standards are constantly evolving. Therefore, it's essential for electrical professionals to stay up to date on the latest revisions and interpretations of the NEC to ensure that their work is always safe and compliant. Continuing education courses, industry publications, and professional organizations can all be valuable resources for staying informed about changes in the electrical industry. By continuously learning and improving their knowledge and skills, electrical professionals can contribute to a safer and more reliable electrical infrastructure for healthcare facilities and other critical environments. The information presented here is intended for educational purposes only and should not be considered a substitute for professional electrical engineering advice. Always consult with a qualified electrical engineer or inspector before designing or installing electrical systems in healthcare facilities or any other complex environment. Electrical work can be dangerous, and it's essential to take all necessary precautions to protect yourself and others from harm. Always de-energize circuits before working on them and use appropriate personal protective equipment, such as gloves and safety glasses. By following safe work practices and adhering to the requirements of the National Electrical Code, electrical professionals can ensure the safety and reliability of electrical systems and contribute to a safer environment for everyone. And always remember to double-check everything. Small errors can lead to big problems, especially in healthcare settings where electrical safety is paramount. A thorough review of the design, installation, and testing of electrical systems is essential for preventing accidents and ensuring compliance with the NEC. So take your time, be meticulous, and never cut corners when it comes to electrical safety. Your diligence can make a difference in protecting lives and preventing injuries.